In this video, I'm going to show you guys how to deal with scientific notation. When working with extremely small positive terminating decimals, it is convenient to express a number as a product of two factors, where the first number is between 1 and 10 and the other factor is of the form 10 to the p, where p is a positive integer. Can also be a negative integer, and I'll show you guys what I mean about that. So converting from a positive terminating decimal to scientific notation. Suppose that n is a positive terminating decimal. If n is less than 1, we're going to move the decimal point to the right of the first non-zero digit. So as you can see, the first few examples here, all of my numbers are less than 1. So we want to get our decimal point to be to the right of the first non-zero digit. So taking a look at our examples, I'll work you guys through. So right here we have 0.4, which is going to be, let me just get my pen. We want to move our decimal point to the right by 1, and moving to the right I always tell people, remember, moving to the right will decrease your exponent. So starting with our exponent of nothing, we decrease 1 place to -1. I want to move, so I'm between the 1 and the 6. So now again, I moved 1 to the right, so -1. Here I'm going to move 1, 2, 3, 4 places, 7.24 times 10 to the -4. This is actually a review lesson, so that's why I'm not getting very detailed. Our next example, we're going to move, so this is a bunch of places, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we want to be between the 8 and the 6 because we want the number in front to be 1 through 10, not including 10, so really 1 through 9. Because we move to the right 10 places, we have a -10. Here I'm going to move 1, 2, so my first non-zero number is 1, 1.0101. Remember, you're just going to write all those numbers afterward, and because we move 2 to the right, -2. Finally, 1, 2, 3 places to the right, 6.7562 times 10 to the -3. In the case of n being more than 10, so these numbers right here, we're going to move our decimal place to the opposite direction, which would be to the left. So moving to the right decreases, moving to the left will increase the exponent. Moving to the right 1, 2, exponent becomes 2. Moving to the right 1, remember if there's no decimal, then it's on the end of the number, 1. Moving to the right 1, 2, 3, 4, 5, 6. That's why your exponent is a 6. Moving to the right 1. And moving to the right 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so left increases, right decreases. Suppose that you're given a number where you're now in scientific notation and you want to write as a decimal form or a terminating decimal. So if my exponent is positive, it's going to swing me out to the right. So I start with 1.2. I'll kind of work it out on the side here so you can see. 1, 2, 3, 1200. 8, 1, 2, 800. Remember, these empty loops get zeros. 1, 2, 3, 4, 5. That's our known number here. So remember, it's 1, 2, 3, and then 2 zeros at the end. That's why these 2 zeros are there. This is going to be 1, 2, 3, and then 4, 5, 6, 7, which is why you have the 4 zeros. 1 place, which is going to be 70, so this one should be 70.004, so just make that correction in your notes. And then this one is going to be 4, so 1, 2, 3, 4, and that's why the decimal point is between the 7 and the 1. Now, if your exponent is negative, you're just going to swing opposite. This number right here, I don't know, I guess when I copied and pasted, these are incorrect. So I'm just going to fix these. I'll fix it on your lesson and I'll repost it. So sorry about that, guys. So I'm going to actually cross these all out and I'll work them out underneath. So 3.1 0.117. You're going to swing 2 to the left. You're going to have 0.03117. That's A. For B, so I would give myself a little space. So 2 is going to be 1, 2, 3, 4. So it's point, and then 3 empty loops, 0, 0, 0, 2. For C, you're going to have 1.0317. So because the exponent is a -1, we're just going to swing 1 to the left. 0.10317. For D, you have 7.4093. So we're going to swing 3 to the left. 1, 2, 3. 0.0749093. And for E, you have 1 times 10 to the -9. So you're just going to swing from the 1. I'm going to give myself a lot of space here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're going to get 1, 2, 3, 4, 5, 6, 7, 8, and a 1. So for some reason, I guess when I copied and pasted these, they didn't copy right. But now you should have the correct answers. So these 3 needed to be fixed. Sorry about that. Convert each number into scientific notation. So again, because this is a number greater than 1, at least the first 2, our decimal point is here, our decimal point is here. Remember, your goal is to get the decimal point to land between the 4 and the 9 here, and between the 5 and the 8 here, 5 and the 2 here. So starting with A, I'm going to swing in 1, 2, 3, 4.993 times 10 to the 3rd power. Remember, we're moving to the left, so our exponent goes up, right, down. For this one, 1, 2, 3, 4, 5, 5.28901 times 10 to the 5th. Now this time you want your exponent to move to the right because you want to land between the 2 and the 6. So moving to the right is going to go negative. -1, -2, -3, -4, -5. Oh, what am I doing here? Not looking at this question right. Sorry guys, let me start that one over. So with this question, it's going to be, I don't know why I thought to move so far. I guess I'm just not awake yet. We just want to be between the 1 and the 2. So 1.20026 times 10. Now remember, we moved to the right, so we moved 1 to the right, -1. Remember, the number in front has to be 1 through 9. So I don't know what I was thinking there. This time we're moving to the left. 1, 2, 3, 4, 5, 6, 7. 1.3890111 times 10 to the 7. We moved to the left, so it went up. For E, we're going to move to the right to get between the 7 and the 7. So we're going to move to the right. 1, 2, 7.7691 times 10. Remember, right goes negative or decreases. And then 1 is just going to be 1.0 times 10 to the 0 because we don't have to move any places. 1 is a number between 1 and 9. Now we're going to convert from our our scientific to our terminating decimal. So if our exponent's positive, we move to the right. So 6.8, we move 1, 2, 680. Moving to the right, 4, 8.0012, 1, 2, 3, 4. Moving to the right, 1, 51.6. Now this is negative, so remember, negative means left. 1, 2, 3. Here, negative means left, so we're going to move just over 1. and here moving to the left for the negative. Okay, so definitely review these rules. Again, this is a review more than it is anything new. We can use our exponent rules that I went over in the last lessons to do actual evaluate expressions involving scientific. So in this first problem, what happened was the 3 and the 2 were multiplied to give us 6. And because we're multiplying bases that are the same, we add our exponents. Here the 7 and the 8 was multiplied to give us 56. Now remember, 56 is not good for scientific because we need it to be a number between 1 and 9 in front, so we'll fix that. Negative 2 plus negative 2 would give me negative 4. Now, because I want my exponent to be on the, or my decimal to be between the 5 and the 6, I'm moving to the left one. Now remember, moving to the left increases your exponent. So an increase by 1, because we moved one place to the left, an increase from negative 4 becomes negative 3. Just to show you the other way, let's say the example said 0.56 times 10 to the negative 4. So this time we would have to move to the right. Moving to the right would decrease the exponent, and it would become negative 5. Here the 8 and the 4 would divide it to give us 2. 2 is good. 8 minus negative 6, remember 2 negatives become positive, 14. This is the example where you apply a power to a power. So 5 squared would be 25. And then a power raised to a power is 14. Again, we have to adjust this decimal. So moving to the right increases, or left increases my exponent by 1. Here, 6 was squared to give us 36. Negative 3 times 2 would give us negative 6. Again, we're going to adjust our decimal by moving 1 to the left. Moving to the left increases my exponent by 1. So hopefully that was a little helpful. Again, if you guys are careful with working through these examples, you will see that working with scientific notation isn't very difficult at all. Please reach out if you have any questions.